Let's look at this Venn diagram that shows a set of 1,000 people. So in this set, we have a subset of US citizens, Canadians, and people from Argentina, Germany, Brazil, and UK. Okay, and within each subset, I have male and female individuals, right? And the probability of, if I randomly pick a person from these 1,000 people, probability of them being a male is 55%, female 45%. What does that mean? It means 55% of all of them is female, 45% is 55% is male, 45% is female, and they are distributed among different nationalities. Okay, that's the sets that I have here. So probability of US is basically this area divided by this total area, right? What if I'm trying to find the conditional probability of Canadian given female, which means I randomly pick a person, that person is female, and what is the probability that if I tell you that that person is female and I randomly pick them, what's the probability that they're Canadian? Okay, depending on what information I have, I can, if this information is not directly provided to me, I may be able to rewrite it as this. We learned previously how to do this, and then I can get this probability. And these are the information that I have. For example, I know that, for example, 25% of Canadians are female, and probability of Canadian, I know that, for example, 30% of the total 1,000 individuals are Canadian. Okay, so I can, and I know, for example, 45% of total population is female. I have this information from these. I can get this one. Let's look at another one, the opposite. I pick someone randomly and I ask you what's the probability that they're female if they're Canadian. Then I can rewrite this as these, depend if I don't have this information, but I have these. For example, I know that of all the females, 30% of them are Canadian, and I have this already. 45% of population is female, and probability of Canadian, I already have it. But what if I don't have probability of Canadian, and I know that Canadians are either female or male, right? So I can rewrite this as the sum of these two pieces. So I rewrite it as probability of Canadian given they are male times probability of male. I always multiply a conditional probability by the probability of the condition. And then the second piece is this. What is this area? It's probability of Canadian given that, which means I'm only looking at the green section. Given that they are female times probability of female. What if I was calculating this and I didn't have probability of female? I want to rewrite that as different. I want to put all these green pieces together. How do I rewrite that? Then I write probability of female in the Canadian space, probability of female given that Canadian times P of Canadian, plus probability of female here, this piece, and so forth. Okay, so more general format, more generalized format of that is I'm looking at the larger set, and these are the states of the world, and in those states of the world, I have some outcomes. For example, these states of the world are the nationality, and these outcomes are age group, for example. But here we are trying to come up with a generalized formula for base. And this piece plus this piece plus this piece plus this piece, which are joint probabilities of OJ with SI, SI plus 1, S8, and S4 for OJ, right? And we want to see how we can use this information. So just a review, probability of SI is this piece, this rectangle divided by the total space. and that joint probability is just that piece, the yellow piece, divided by the total space. And if I'm looking for this conditional probability, probability of OJ given SI, when we say given SI, it means I'm looking only at this piece. If I'm looking only at this piece, what is OJ? OJ is this part. So that probability is graphically is this, and I want to rewrite that as joint probability of SI and OJ over probability of SI. Basically, I'm dividing this. We learned that probability of SI, joint probability of SI and OJ is this, and I'm dividing that by this, and these two denominators cancel out, so I'm left with this. But anyways, I also learned to rewrite that as this probability, swap these two, condition goes here, and multiply condition here, and we learned that in the previous video. So, and if I don't have SI, probability of SI, I want to rewrite SI as its pieces, sum of its pieces, which is these three pieces. Alright, probability of SI with O3, see, this comes from O3, and this piece, which is joint probability of SI and OJ. And these joint probabilities, I can rewrite them as SI given O3 times probability of O3 all the way to, I rewrite that as probability of SI given OJ. This is the formula we had from conditional probability. I can rewrite a joint probability as this. Okay, so let's continue and complete this piece by writing the formula for P of SI. So P of SI is sum of all of its little pieces, P of SI given OI, which means intersection of SI and O1, intersection of SI and OJ. I'm gonna put all the pieces together. Note that they all start with SI, and note that condition is multiplied by condition, by P of condition always. Okay, let's look at an example. Let's say these probabilities are given to me. P of A 25%, P of B 75%, P of X given A, and we don't even know what these are, but we want to practice the formula. If I ask you what's probability of A given X, is it here? A given X? No. So I rewrite it as, swap these two, X given A times P of A, X comes down here, P of X. So these two are here. This is missing here, so I'm gonna add all the pieces that have P of X together to form this larger piece, which means this part and this part. They are both P of X, just in different domains. X given A, X given B. So P of X given A times P of A plus P of X given B times P of B. Okay, what if I ask you this? P of, what's the probability of B given Y? Alright, is it here? No. So rewrite it as probability of Y given B times P of B. P of Y goes here. I have these two pieces, probability of Y given B 0.6, probability of B 0.75. I have those, and I rewrite P of Y as pieces that have P of Y. P of Y given B, P of Y given A. I rewrite those as this, and this is the final formula. What if I ask you what's the probability of A given Y? So they have, these two probabilities have the same domain, and these two are complements. So because they have the same domain, I can rewrite this as 1 minus probability of B given Y, which is 1 minus 0.72, which is 0.28.